Hello everyone. Welcome to our first discussion on a new irrational number that you've probably seen before. This irrational number has no pattern in the decimal uh, system, and it's called pi. And what pi is, so let's define it. Pi is the ratio of the circumference of a circle to its diameter. So I have a diameter is the distance across, and the circumference is, if I took a string and I wrapped it around, the length of that string would be the circumference. So it's the circumference to the diameter is what pi is. This is used a lot in mathematics, and the way to approximate it, the first person to approximate it in a more mathematical way was Archimedes. Archimedes devised it around 250 BC, so a long time ago, and he came up with the approximation that it was 273/71. It was between that number and 22/7. So that pi was between these two fractions. And Archimedes didn't even have the decimal system. He didn't have calculators. He didn't have anything that we have in the modern day that we can use to approximate pi. So I'll just go through an example here of one of the things that he did. He took polygons like the hexagon and inscribed, that means put inside the circle. And we're going to say this has a radius of 1. And then he took another polygon outside, so hexagon, just like that just touches on the edges. And he said, okay, so if I'm going to compare the circumference of this circle to its diameter, and then I'm going to compare the polygon's diameter versus its perimeter, right? So let's just take a look at this hexagon. So this hexagon, we can tell by experimentation that the sides are equilateral. So this would also be 1. So the side lengths would be 1 for the inside circle. And so be 1 times 6. So the perimeter of the inscribed, so I'll just say piece of I, the perimeter of the inscribed would be 6 times 1, which is 6. And the perimeter of the circumscribed, so here, since the edge is touching the circle, that would be a distance of 1 because our circle has a radius of 1. So let me kind of blow that up a little bit. So if this distance was 1, what is the side length? So it makes equilateral triangles, so we can say this is the side length, and this is the side length over 2. So I can use Pythagorean's theorem, which he had at this time as well. Pythagorean's theorem. Pythagoras actually came before 250 BC. So I would take 1 squared plus s over 2 squared equals s squared, and I could rearrange this formula to get 1 plus s squared over 4 equals s squared, and then I subtract s squared over 4 from both sides. So I get 1 equals s squared minus s squared over 4, which is the same as 4/4. And then I have 4 minus 1, so it's 3s squared over 4 equals 1. And then I multiply, I want to make this 1s squared, so I multiply by the reciprocal on both sides. So I get 4/3 equals s squared, and then I square root both sides. So I get square root of 4 is 2, and the square root of 3 is the square root of 3, so you get an irrational number here. So the side length is that, and then so you say the perimeter then would be 6 times that, so 6 times 2 is 12 over square root of 3. Now, he came up with fractional approximations for these square roots that he used, and who knows how he did that, with the tools that he had, but he was able to use fractional approximations that, were pretty large in their approximation, fractions over the top of another fraction. But anyway, he was able to say, well, it's between 6. 6 is too small, right, because it's inside the circle. And this is 2 times pi, right? Yeah, because we say the circumference is pi times the diameter, but we're using the radius, which is 2 radiuses, so 2 pi times the radius is the circumference. So 2 pi is between 6 and this 12 over the square root of 3. And so that's the way that Archimedes went about approximating it. Now, he didn't stop there. He went on to do a 96-sided polygon, and that's when he came up with his 22/7. And what was it? Let's get back to here. Oh yeah. Oh, that was the high end was 22/7, and the low end was 223/71. So that's how he did it.